Dear A-level students, welcome to the video Statistics 2 Hypothesis Testing. Why we need to study hypothesis testing? A sample of voters are asked who they will vote for in an election with two candidates, candidate A and B. If 53% of voters say they will vote for candidate A, can you actually be certain that candidate A will win the election? DNA evidence is presented in courtrooms. A judge and/or jury has to make a decision based on this evidence. How can the judge or jury be certain the evidence is true? A pharmaceutical company testing a new drug treatment for COVID-19 observes a positive effect in people using it. How can they test if the effect of new drug treatment compared with the other treatments is significant? These are some of the questions which are going to be answered through this chapter. Introduction to hypothesis testing. Suppose the case in which you have a set of dice, some of which are biased toward 6 and some are fair. You pick a dice at random and you roll it 16 times. Now the question is that how many times do you need to get a 6 to convince yourself that this dice is biased toward 6? Now let's have some different cases of number of 6 you obtain and have a simple calculation. First, we know that when you throw a dice, the number of 6 obtained has a binomial distribution with, as I said, 16 times is number of trials, and probability of success for an ordinary dice, which is 1 over 6, because probability of 6 is 1 over 6. Now, let's first calculate probability of the case you get no 0, so success is 0. Combination of 0, 16, 1 over 6 to the power of 0 and 5 over 6 to the power of 16, giving you an answer of 0.0541. So probability of x less or equal to 0 will be equal to the same number, because there is no case less or equal to less than 0, so it will be 0.541, correct to 3 significant figures as a percentage. Now, probability of x is equal to 1, combination of 16, 1 over 6 to the power of 1, 5 over 16 to the power of 15, which is equal to 0.1731. So probability of x less or equal to 1 means probability of x is equal to 0, or probability of x is equal to 1, which is equal to 0.2272, which is 22.7%, correct to 3 significant figures. Now probability of x is equal to 2 will be equal to combination of 16 to 1 over 6 to the power of 2 and 5 over here it was 6, 5 over 6 to the power of 14, which is equal to 0.2596. so probability of x less or equal to 2 will be probability of x is equal to 0, 1 or 2, which add up to 0.4868 equal to 48.7%, correct to 3 significant figures. Now probability of x is equal to 3 will be combination of 16, 3, 1 over 6 to the power of 3, 5 over 6 to the power of 13, which gives you 0.2423. So probability of x less or equal to 3 will be sum of all these cases, which is 0.7 T2 91, which is 72.9%, correct to three significant figures. Now for the case we have 4, so combination of 16 4, 1 over 6 4, 5 over 6 to the power of 12 is equal to 0.15 75. Then probability of x less or equal to 4 will be 0.88 66, which is 88.7%, and probability of x is equal to 5 is equal to combination of 16 5, 1 over 6 to the power of 5 and 5 over 6 to the power of 11, which is 0.0756. So then probability of x less or equal to 5 will be 0.9622, which is 96.2%, correct to three significant figures. Actually, these probabilities tell us, for example, here, almost 89% of the times you expect to get 6 in 16 trials to get a 6 at most 4 times, or in almost 96% of trials you expect to get 6 at most 5 times, or in other words, the probability that getting 6 times 6 or more is less than 4%. Using what we found in the last page, you can say that probability of x greater or equal to 5, which x is number of 6 obtained in these 16 trials, is 1 minus probability of x less or equal to 4, which is 1 minus 0.8866, which is equal to 0.1134, giving you an answer of 11.3%, correct to three significant figures. Or probability of x greater or equal to 6 is equal to 1 minus probability of x less or equal to 5, which is equal to 1 minus 0.9622, which is equal to 0.0378, giving you an answer of 3.78%, correct to three significant figures. As you see in this diagram, the shaded region shows the probability of x greater or equal to 5, x is equal to 5, x is equal to 6, x is equal to 7, 8. If you calculate for 9, 10, 11 up to 16, you will see that they are tending to 0. And as you see in this graph, probability, actually the shaded region shows probability of x greater or equal to 6. This column shows probability of x is equal to 6, here equals to 7, equals to 8, and after 8 it tends to almost 0. But in both graphs, the previous graph and this graph, the region after this red line shows actually 5% of total probability. So in the previous graph and this graph, the region after this red line represents almost 5% of probabilities. Now, we subdivide the regions into two regions actually. This region, I label it rejection region, and this one acceptance region. So after the red line and before the red line. If you remember, the region with a probability of x greater or equal to 5 started from here. So some portion was situated after the red line and some portions were actually before the red line. But here probability of x greater or equal to 6 is completely included after the red line. Now, if we choose this 5% as a significance level, then probability of x greater or equal to 6 is completely in the rejection region, but probability of x greater or equal to 5, it is completely located in the rejection region, but here no. So that's why 6 will be called critical value. So what is the definition of critical value? So after 6 is completely in rejection region, but before that is not in the rejection region. As you see, probability of x equal to or greater than 5 was 11.3%, but probability of x greater or equal to 6 was 3.78%. Now here you clearly see that this is greater than 5%, but it is less than 5%. That's why it is not completely in the rejection region, but it is completely in the rejection region. So we will have two regions: rejection region, acceptance region. This is this 5% will be called significance level, and here 6 will be called critical value. Now here in this part we are going to learn some definitions that we are frequently using in this topic. First, a hypothesis is a claim believed or suspected to be true. Then a hypothesis test is the investigation that aims to find out if the claim could happen by chance or if the probability of this actually claim happening by chance is statistically significant or not. Next definition, null hypothesis. The claim is called null hypothesis, which is denoted by HO or H0. It is actually the default hypothesis. Next one, alternative hypothesis. If you are not going to accept the null hypothesis, then you must have an alternative hypothesis to accept, which is denoted by H1, or in some texts you will see it is denoted by H sub A. In both cases, null hypothesis and alternative hypothesis, these actually two hypotheses are shown by statistics parameters like probability or mean. Example number 1, experience has shown that drivers on a Formula 1 racetrack simulator crash 40% of the time. Zander decides to run a simulator training program to reduce the number of crashes. To evaluate the effectiveness of the training program, Zander allows 20 drivers one by one to use the simulator. Zander counts how many of the drivers crash. 4 drivers crash. Test the effectiveness of Zander's simulation training program at the 5% level of significance. Now, first let x be the number of drivers that crash. So it is clear that x has binomial distribution with 20 as n, and it says 40% of the time, so the probability is 0.4. Now, null and alternative hypothesis. So the question initially says that 40% of the time crash occurs, so probability of crash is 0.4. Now, Zander has run this training program to reduce the number of crashes, as you see here, to reduce. So the probability is going to be less than 0.4. Now, here as we are actually planning to reduce the number of crashes, and we are going to check whether probability of x less or equal to 4 will be located in the rejection region or in the acceptance region. Now, probability of x less or equal to 4 will be equal to probability of x is equal to 0, or probability of x is equal to 1, or x is equal to 2, or probability of x is equal to 3 plus x is equal to 4. Now is equal to combination of 0, 20, 0.4 to the power of 0, then 0.6 to the power of 20 plus 21, 0.4 to the power of 1, 0.6 to the power of 19 plus 2 and 3, 0.4 to the power of 2, 0.6 to the power of 18 plus 20 and 3, 0.4 to the power of 3, 0.6 to the power of 17, and the last one, 20 and 4, 0.4 to the power of 4, 0.6 to the power of 16, which will be equal to 0.050952, which is 5.10% correct to three significant figures. And the significance level here is given 5%, so we denote it by alpha, so alpha is 5%. Now, as here probability of x less or equal to 4, be careful, this sign always follows this alternative test sign, so it is less, it will be less or equal. Now, probability of x less or equal to is equal to 5.10%, which is greater than 5% significance level given in the question, so it is not in the rejection region. Now we decide that there is not sufficient evidence to reject HO, or you can say accept H1, because here probability of x less or equal to 4, it is not in rejection region, so HO is not rejected. Of this example, consider this alternative scenario. Suppose only 3 of the 20 drivers crashed after attending Xander's simulator training program. At the 5% level of significance, what would you conclude? Now, we calculate probability of x less or equal to 3, which is equal to 20, 0, 0.4 to the power of 0, 0.6 to the power of 20 plus 120, 0.4 to the power of 1, 0.6 to the power of 19 plus 2 and 20, 0.4 to the power of 2, 0.6 to the power of 18, and 23, 0.4 to the power of 3, 0.6 to the power of 17, which gives you an answer of 0.01596, which is equal to 1.6%, which is less than 5% significance level given in the question. So it is in the actually rejection region. So there is not enough evidence actually to, you can say, reject, sorry, to reject H1 or accept HO, because it is in the rejection region. In the rejection region means that HO is not accepted. There is not enough evidence to accept HO, or you can say that H1 is not rejected. Now, another part of the same example, consider this alternative scenario. Suppose 4 drivers crashed and you were testing the effectiveness of Zander's simulator training program at the 10% level of significance. Now, in this part, alpha is equal to 10%, and there are 4 crashes, so probability of x less or equal to 4 will be 5.10%, which is less than 10% significance level given in the question. So it is in the rejection region. So there is not enough evidence. Here in the rejection region, it means that HO is rejected. There is not enough evidence to, you can say, accept HO or to reject H. To carry out a hypothesis test, you need to take the following steps. First, define the random variable and its parameters. As you see in the last example, the random variable had binomial distributions, and the parameters were also given the information given in the question. Step 2, define the null and alternative hypothesis. Third step is to determine the critical region. Now, step 4, calculate the test statistic. Step 5, compare the test statistic with the critical region. And 6 is to write your conclusion in context. Example number 2, a study suggests that 10% of the world's population is left-handed. Bailey suspects that being left-handed is less common amongst basketball players and plans to test this by asking a random sample of 50 basketball players if they are left-handed. Part A, find the rejection region at the 5% significance level and state the critical value. Part B, if the critical value is 2, what would be the least integer percentage significance level for you to conclude that Baylin's suspicion is correct? Now, so first we should define the random variable. Let x be the random variable which shows the number of basketball players, and P be probability of being left-handed. So now at this step we need to define our null and alternative hypothesis. So the question says that the first claim is 10% of the world's population is left-handed. So probability of being left-handed is 0.1, and H1, now it says that he actually suspects that it is true, and it says it is less common. So he believes that the probability of being left-handed is less than 0.1. Now alpha is also 5% as given in the question. 5% here, significance level. Now, we are looking for actually the critical value to decide about rejection region. Now, critical value is such that, for example, probability of x, if k is critical value, probability of x less or equal to k should be less or equal to 5% to be included in the rejection region. And if you take one more step, for example, if k is turned to become k plus 1, you should get out of the critical region and it should become more than 5%. Actually, k will be the boundary of the rejection region. So in k or up to k, you are included in rejection region. It should be less than 5%. 5% is given in the question. And right after k, which is k plus 1, you should be out of the rejection region, so it should be more than 5%. Now, here let's calculate the corresponding probability for each case. Now, here k and probability of x is equal to k. Now, it is 0, 1, or 2 here, we check. 0.0052, probability of x is equal to 1 will be equal to 0.0286, and x is equal to 2 will be 0.0779. Now, so probability of x less or equal to 0, which is 0.0052, converting to percent, it would be 0.01% actually. Probability of x less or equal to 1, it will be 0.0338, which is equal to 3.38%, which is less than 5%. You are still in rejection region. Probability of less or equal to 2 will be equal to 0.1117, which is 11.17%, which is more than 5%. So before 1 you are in rejection region, and after 1 you are in acceptance region. So critical value is now 1. And the rejection region is actually x less or equal to 1. Now, second part, if the critical value is 2, so let's calculate probability of, here is B part, here it was A, probability of x less or equal to 2, which was calculated here 11.17%. So it means that x less or equal to 2, it should be included in the rejection region, and the least integer percentage will be, so it should be 12%, because before 12% will be included in rejection region, and after you will go to acceptance region. So 12% must be chosen as the significance level. The third example, a regular pentagonal spinner is spun 10 times. So in its 10, it lands on the red 5 times. Test at the 4% level of significance if the spinner is biased towards red. Now, first let x be the number of times the spinner lands on red actually. So X will have binomial. This experiment has been done 10 times, and we know that probability of red is 1 out of 5, which is 0.2. Now, significance level is 4% as given in the question, and it says that we are supposed to check whether it is biased or not. Now, first, null hypothesis B is equal to probability of actually red is 0.2, so it is fair, 1 out of 5, 0.2. But in order for the red part to be biased, the probability should be more than 0.2. So probability is more than 0.2 if it is biased, as it is claimed. Now, here I told you this test always follows this sign. So 4 times, as it is given in the question, sorry, it is 5 times it lands on the red. So probability of X more or equal to 5 must be checked. Follow this alternative sign. Now, probability of X greater or equal to 5 will be 1 minus probability of X less or equal to 4, which is equal to 1 minus, now n is 10, so 10, 0, 0.2 to the power of 0, 0.8 to the power of 10, then plus 10, 1, 0.2 to the power of 1, 0.8 to the power of 9, plus 2, 10, 0.2 to the power of 2, 0.8 to the power of 8, plus 3, 10, 0.2 to the power of 3, 0.8 to the power of 7, and last one, combination of 10, 4, 0.2 to the power of 4, and 0.8 to the power of, here is 6, which is 0.0328, which gives you 3.28%. Now, as you see, 3.28%, the significance level in the question is 4%, is less than 4%. So it is in the rejection region. So therefore, I write it here, therefore, there is not enough evidence to accept HO or to reject H1. So HO is rejected. Or you could say that there is enough evidence to show that this spinner is biased towards red. Example number 4, Ara is elected club president with the support of 52% of the club members. 1 year later, the club members claimed that Ara doesn't have as much support anymore. In a survey of 200 club members, 91 said they would vote for Ara. Using a suitable approximating distribution, test this claim at the 5% significance level. Now, again, first let X be the number of people who vote, the number of people who vote for Ara. Then X has binomial distribution with 200, because 200 are actually asked, and 0.52, because 52% of the club members were supporting Ara. Now, so HO will be P is equal to 0.52, and H1 will be, as it is claimed that it doesn't have as much support anymore, so the support is less, so P less than 0.52. Now as actually here NP is greater than 5 and also NQ is greater than 5, so it can reasonably approximated by a normal distribution, and mu will be NP, which is 200 times 0.52, which is 104, and variance will be NPQ, which is equal to 200 times 0.52 times 0.48, which is 49.92. So this will be converted to these two, null and hypothesis. So mu is equal to 104, or mu is less than 104 here. Now, so the significance level in the question is given alpha 5%. So we calculate probability of, it says 91 said they would vote for Ara. So x less or equal to 91 is calculated. But it will be equivalent to x minus mu when we are going to standardize it, minus mu divided by sigma less or equal to, now continue the correction, 91.5 minus mu divided by sigma. So it will be probability of z less or equal to 91.5 minus mu is 104 divided by radical 49.92, which is equal to phi of negative 1.769, which phi of negative number is 1 minus phi of corresponding positive number 69, which is equal to 0.0384 or 3.84%. Significance level was actually 5%, is less than 5%. Now it is 5%, so it is in the rejection region. So the conclusion is there is not enough evidence to accept HO. So it means that we are not accepting HO. It means that the Ara support has reduced actually as it is claimed. Example number 5. Past records show that 60% of the population react positively to a cream to treat a skin condition. The manufacturers of a new cream to treat these conditions claim that more of the population will react positively to the new cream. A random sample of 120 people is tested and 79 people are found to react positively. First part, does this provide evidence at the 5% significance level of an increase in the percentage of the population that react positively to this new treatment? Part B, find the critical value. Now for the first part, part A, let x be the random variable which shows be the number of people who have positive reaction to the new cream. So x will have binomial distribution weight as 120 are tested, so n is 120, and it says 60%, so 0.6 is the probability of success here. NP and NQ both will be greater than 5. Now, first I write for this condition for binomial, null hypothesis will be p is equal to 0.6, and they are claiming that it is more, so p is more than 0.6. Now, as I just mentioned, because NP and NQ are both greater than 5, so it can be reasonably approximated by normal distribution with mu NP, which is equal to 120 times 0.6, which is 72, and variance will be NPQ, which is 120 times 0.6 times 0.4, which is 28.8. Now it can be approximated by normal distribution with mu, which is 72, and variance 28.8. So HO will become actually mu is equal to 72, and H1 is mu. It is going to disclaim that there is an increase, so more than 72. Now we calculate, it says 79 people are found to react positively. So we calculate probability of x greater or equal to 79, as this sign follows this alternative sign, which is equal to 1 minus probability of x less than 79. Now after using continuity correction, it will be probability of x minus mu, which is 72, over actually radical 28.8 is less than 78.5 minus 72 over radical 28.8, which will be 1 minus phi of 1.211. You know how to use the table to calculate this probability. Will be equal to 1 minus 0.8871, which is equal to 0.1129, which is 11.3%. Significance level is 5%, so it is greater than 5%. Now I write the conclusion here. There is, as 11.3% is more than 5%, so it is in acceptance region. So there is not enough evidence to reject HO. It means that this evidence doesn't show increase in the number of people who have positive reaction toward this new cream. Okay, now for the second part, find the critical value. Now we know that this is rejection region, it is acceptance region, and we know that we normalized actually X with a normal distribution, which means 72 and 28.8 as the variance. Now we know that if K is the critical value, probability of X more than K is less than 0.05% to be included in the critical rejection region. So 1 minus probability of X less or equal to K should be less than 0.5%. So 1 minus probability of X minus 72 over radical 28.8 less than K minus 72 over radical 28.8 must be less than 0.05. Transfer to the other side, and then it will be actually 1 minus phi of K minus 72 over radical 28.8 is less than 0.05%. Transfer to the other side, so we can write phi of K minus 72 over radical 28.8 is more than 0.95. Now, so if you check the table, you will find k minus 72 over radical 28.8 must be greater than 1.645. After doing cross multiplication, k must be greater than 80.8. So the first integer after 80.8 is 81. So 81 is the critical value.